Hey everybody, we're going to start with the next session. The next session will be uber cool, because this will talk about things which will most likely happen in 5 years, and maybe tomorrow as well, but most likely in 5 years. We're going to have Aleksander and then three more guys on the stage giving separate speeches, so they need their own time to see. That was the comment to the sound guys. And there will be 3 speeches about different aspects of hardware and Internet of Things technologies. But first, I would like to invite on the stage a guy who speaks perfect German, and he has started a hardware accelerator, which was the 3rd one in Europe, in Tartu. This is the same village where I come from. And his name is Aleksander, and he's an electronics engineer. Aleksander, here's your microphone. Give him a big applause.
Thank you.
This guy, and they have helped us to organize the hardware hackathons we do in Tartu and all this cool stuff. Thank you.
Yeah, thank you, Brit. So my name is Aleksander. I'm co-founder at BuildIT. So we're a hardware accelerator. Actually, the only one in Europe running a 3-month program and investing. And there's very few accelerators worldwide who invest in real tangible stuff. But today it's not about us. It's about hardware, and few people I invited here to give you a speech. So we call it the panel, just for the heck of it. But actually, it's 4 presentations. So I'm super excited. The panel is called The Panel. The track is called 5 years from now. And we investors, we like to pretend what we know about the future. So we know what the future brings. We invest in future success stories. Actually, we don't, right? So it's a lot of gut feeling, it's a lot of guessing. But there are few things we do know, and about hardware, for example, what is absolutely certain is that everything which can be connected to the internet will be connected to the internet, right? So there's a prediction that in 2020, we have roughly 40 to 120 billion internet-connected devices. And that's awesome. So that's why we are having this track today. And without any further ado, I want to introduce the first speaker, Adam. And Adam is a serial entrepreneur. Adam has a daughter who is 5 years old, who knows how to program Arduino. And she thinks that Raspberry Pi is an actual pie, which you can eat. And this is pretty cool. How we met was that I read an ebook which Adam wrote about crowdfunding. And I was like, fuck, this guy is cool. I have to meet him. So I reached out. We had a chat over Skype. We invited him to Estonia. He has mentored our teams. And now he's here back as a speaker. So Adam, if you want to come on stage, floor is yours.
All right, thank you very much. Hi, everyone. My name is Adam Benzion from Hackster, from Seattle. I'm really happy to be here. It's my 2nd time in Estonia, and I really love this place, and I love Tallinn. It's a beautiful city. So thanks for having me. So I'm going to talk about open source hardware. So a lot of you know a ton about open source software, but the world is actually embracing open source on the hardware side. And I'm going to talk about some of my personal experiences around open source hardware and why I think it's great. And if any of you will be working on hardware projects, you should definitely consider working with open source, because it's going to change the way you build stuff. All right, so I come from Seattle. It's also a really nice place. And for those of you who don't know Seattle, it's the home for Amazon. This is their new headquarters. They build these crazy biodomes in the middle of the city. It's the home for Boeing. We make airplanes. And horrible, overpriced coffee. Starbucks is there too. But it's also home for another company, Microsoft. And I didn't start my career there, but I spent almost 8 years at Microsoft at an era where open source was the enemy. They would tell us that open source is going to lose. We have to win. It's a bad thing. People should not be sharing. And I used to sit there in those meetings and kind of have this feeling that maybe I don't belong here. I kind of like the penguins, you know? I'm kind of like, maybe a penguin myself. I like sharing. I think people should actually co-innovate and be more open about this. And then I had another really, really dark secret that I keep it hidden from everybody else at my job. At home, I was actually eating apples. I was actually using like a MacBook Air, and every time my friends from Microsoft came over, I was like, take that silver thing and shove it somewhere and open my Windows machine. And there's nothing wrong with Windows, and I do love Microsoft. But it was an era that it was bad. Apple was bad, Google was bad, only Microsoft was good. And by the way, that company changed. It's a new company today. It's totally open, and they're doing things the right way, so I have a lot of respect for them. But that was back in the day. And then I kind of realized that I'm actually like a half pirate, half open source, using Macs at home, and maybe I shouldn't be working for Microsoft, and I decided to leave, and that's when my journey into hardware really began. And I had a little problem. I had an iPhone, I ran out of power, and this was like in 2009, and I decided to build this like battery case, which sounds kind of silly today. It's just a battery case. But I had this little thing, and I knew how to do it better and prettier. And I built this company, and it was completely closed source. Everything was custom made. Everything had to be patented. I was so kind of like old school about it. And I got really lucky, and I sold the company. And then I had to work for another company and shipping all the products and doing all this legal stuff. But again, I had the feeling I'm still not doing this right. Like, there's so much openness that has to happen in the world for people to innovate, and I'm not part of it. And I decided to rebel again. And after a few years of doing all this stuff, I left and started another company. And now I became a total pirate because I started a company that open sources everything, any hardware design, any electronic that we can get our hands on. We encourage a community of developers and hackers and makers to create a bunch of products, share them online. It could be a thermostat or weather station or any kind of like IoT apps, and tell people, how did you build it? Share the source code, any schematics you've done, any components, which is called bill of materials. You hear this word a lot in hardware, the BOM. They share it. Other people can come and replicate it, and it's completely free and completely open. And I really start thinking a lot about patents, too, that they really are important if you're like a researcher and you've spent so many years and so much money and you're doing something so special, you need to protect yourself. But for the most part, a lot of patents like what I've done, it's not that meaningful. It was actually something that I could have shared with everybody. And I actually looked at that US PTA, like the PTO. It's that place in America where you actually book patents. And you actually have this kind of patents in the US. It's real. People actually patent this kind of stuff. So I kind of feel we should just take it easy with the patents and just share more. So I became a bit of a pirate and an open source hardware pirate. And that's my journey. So the basics of open source and open source hardware in particular are very similar to open source software. I mean, this was born from the open source software movement, that you have the rights to study, modify, distribute, make, and even sell other people's designs that were shared based on an open source license. It's not even a license. And then the open source hardware community created this Bible, and the Bible said that if you want to take some open source design, nobody should discriminate against you because you're from a different group, or maybe you're doing something in a field that I don't like and you shouldn't be using this, or I want you to build stuff for specific verticals or products, or I want to restrict your hardware or software. It's really completely technology neutral, it's completely open, and it's about everybody building everything together. So effectively, theft is encouraged. Everybody say, you should kind of steal from me because it's probably going to help me, it's going to help you, it's going to help the world. So theft is really encouraged. So let me give you an example, a really cool example. So did you guys hear about this company called Arduino? So I was told that you're not going to answer. Yes. Thank you very much. Okay, and for that, you're getting a gift, an Arduino Maker 1000. Yay! So Arduino started this whole thing in Italy. A bunch of actually teachers, they started sharing like these little designs of these Arduino boards to teach people in their university how to actually build electronics and do schematics and do really basic microcontroller stuff. So they make a completely open source prototyping and learning tool. And a lot of people, like especially like people around your age, millennials, that are interested in a little bit of software and hardware, grew on the foundation of what Arduino said. And then there's another company called Particle in San Francisco. And that guy, his name is Zach. He's a the CEO, and he said, I really love Arduino, it's so cool, but it doesn't have a Wi-Fi chip on it. It's just like a microcontroller, so I could just do basic compute. I wish it could connect to the internet, because I'm like in this IoT era. I do everything on the cloud. So he took an Arduino design, added a Wi-Fi chip to it, called it Particle, and now you have an Arduino-based product that he sells that has Wi-Fi in it. There was another guy, I think he's in Boston, and he said, I really love what Arduino did, and I love what Particle did, but I'm like a Bluetooth guy. I want to use Bluetooth with my Arduino. So I'm going to take that Particle board with Wi-Fi, and I'm going to create a component on top of it, and it's going to be Bluetooth enabled. So now this guy built this product called Blues, and Blues actually created an Arduino board with a Particle board, which has Wi-Fi, and also Bluetooth. Nobody lost. Everybody won. The users are winning. 3 companies are creating value for themselves. They're all supporting each other. The code base is being shared. And open innovation is happening faster, and it's better, and everything gets more connected. So it's a really an amazing world, and it's really fun to see how companies are supporting each other through this. And of course, it's not as simple as I make it. There's some competitive pressure sometimes, but for the most part, it helps everybody. Then you see even more bizarre things. You see entire companies that are based on open source hardware. So there's a company called SparkFun, started by an electrical engineer that also in college, and it's about $50 million in revenue right now. And the entire things, everything they sell, it's all open source hardware. Only. They sell nothing that has IP built onto it. And that's also really interesting, right? Like, how can you build a company that everything you do is open, so anybody in the world can copy everything you build? So I talked to the CEO, and he's a really smart guy, and he has an amazing TED Talk, too, about this, so you can kind of look him up. That's his name, Nathan. And he said this. He said, at the end of the day, SparkFun is successful because of the products, value, and service we deliver, not our IP portfolio. So none of us consume IP portfolios. We buy products. We use SDKs. We talk to APIs. We don't really care whether somebody booked a patent or not. And in fact, if they did, it's kind of scary because they're probably going to sue you one day. So it's best to really work with the open world versus the closed world. And then it gets even better. So now the big guys are part of this. Take a company like Intel, which, by the way, is a huge contributor to the open source community in software and hardware. But a lot of the chipsets are very closed. So there's this product called Edison. It's like a 2-core x86 Intel microprocessor, and it's very closed. It's top secret. It's Intel. But they took this thing, and they embedded it inside of like an Arduino compatible board, and effectively created a closed environment into an open environment, and with that opened the market for like people like us, to use an Intel product that typically hackers and makers will never touch. So for that, I give Intel half a pirate score. They're not full pirates, but half pirates. But it's amazing to see even a company like Intel that does this kind of work. So we talked about Arduino. They're definitely like the icon. They're like one of the most common boards that people buy to learn and to use and to create prototypes. And then there's another company, you probably all heard of it, it's called Raspberry Pi. And they're like just as big as Arduino. People are crazy about them, and they're just as big as this part of this community as everybody. But here's something interesting, and that's where things kind of get complicated. While Arduino is fully open source hardware, software community, Raspberry Pi kind of snuck in there, sat between everybody. Hey, I'm part of the crew. But actually, it's not open source. It's really closed. But the community and the way people use Raspberry Pi is really open, totally innovative, totally open, and totally all about sharing. So for that, I'll give Raspberry Pi a little pirate score, and Arduino gets the big guy, the big pirate score. But again, I love both companies. They're both doing amazing work. But it's also interesting to see that some companies that you think are playing in this field are not doing as much as they could. So the idea is that open source hardware is amazing. It really creates innovation. It helps people like you and I. And by the way, I'm not an engineer by trade whatsoever. I'm not even like a technical person. I just taught myself some hacking skills. I can write a little bit of code. I can connect a few things. But even for a guy like me, I can actually go and build things and kind of figure them out just using a tutorial online. And I can innovate. I can think about stuff that I could have never have done before if I don't have a degree doing that. So it really, really makes innovation easier. And it's everywhere. So let me give you some examples of where I keep seeing open source hardware. So first, everybody heard about GitHub? Yes, of course. So everybody tells me, oh, are you building Git for hardware? I'm like, no, Git actually is for hardware because all the hardware runs software, and Git has so much software that runs on again, microcontrollers, microprocessors, connect sensors, IoT. It's all on Git, so it's an incredible resource when you want to learn building hardware. Then you think about 3D printing and CAD. Obviously, this country produced one of the most amazing companies in the world, GrabCAD, that does a lot of sharing and modeling and mechanical engineering, but also Thingiverse, right? You can actually find different types of designs that people just share, and they can be part of your electronics creation, and you can just replicate it because it's open source. It's made for you to take, replicate, or innovate from. So this is my pitch. So also my company does the same thing. We share all this stuff that I mentioned earlier. We share online. We allow people to figure out any type of idea, whatever you want to build, irrigation system, monitoring system, home security system, and somebody will show up from some country and will just post the exact instructions of how they built it, and anybody in the world can actually replicate it. So it's a really, really empowering movement, and the amount of information and content that exists out there is just unbelievable. Again, so if you want to do this, that's how you do it. And then you look at Kickstarter. So many of the projects on Kickstarter use open source hardware and open source software, obviously. Again, because it's the easiest way to market, and at the end of the day, they sell a product and a service, and the fact that it was based on open source doesn't hurt anybody. And in fact, maybe because of that, some other people can co-innovate with them and create accessories that will work with their products. So think about that as well, that when you open something, a lot of other people can play with your product and create an ecosystem for it. And the list goes on and on. This company, Unique, creates prosthetics that are 3D printed. And they have this kind of like a standard prosthetic design that is completely open. And people can actually take it and innovate from it and on it and do something really helpful for the world too, right? So they don't just say, oh, it's ours, we're going to sell prosthetics, arms, and legs to people. They say anybody who needs one can actually create from our repository. This company created an open source gaming system. Last year, I visited a company in Arizona that builds these crazy automobiles. They're very expensive, so it's not the best example, but they're open sourcing the manufacturing process, a lot of the way they build the car. And in fact, they even released one of these cars that was completely 3D printed. So they even show how you can even theoretically 3D print a car. And then, again, you see all the big guys are doing cool stuff, like Autodesk is open sourcing the way they build their 3D printers. Facebook, about a week ago, or 2 weeks ago, or 3 weeks ago in their conference, announced this amazing 360 virtual reality sort of a camera that is based on their open hardware initiative. And it's completely going to be using open source and be open source in itself, so anybody can actually innovate on it and from it. So very impressive. Google last week announced Google Home, which is like a home automation AI voice interface device that you talk to at your house. Completely open. Anybody can actually innovate and build on top of it. And one of my favorite ones is Tesla Motors. Elon Musk, amazing guy. So he even says, all our patents belong to you. So if you ever seen a Tesla, I'm not sure if you have some of them here, but they really are amazing cars. They're beautiful and technologically so advanced, and there's so many things they do. It just takes the automobile industry years and years ahead of its time. And to think that he will share everything that he's learned and invested in real hardware that is really hard to do, that is just remarkable. And he's doing this to advance the society, advance the industry, and he's going to learn a lot from it. And even a company that's traditionally completely closed is Toyota. They created the first functioning fuel cell automobile. Same, completely open. Over 5,000 patents. That's like a lot of patents. Anybody here is a patent lawyer? Maybe not. But that's like a lot of work. And to say, after all this work, I'm just going to open it and you can all copy my stuff. Unbelievable, right? So they get a little pirate. It's big work, but they just did it for one car, so they should do more. So my pitch to you is that share and be part of this community, and don't feed the trolls. If you've done something really, really hard that took so much out of you, and you really are afraid that somebody's going to copy you and damage what you've done, absolutely protect yourself and get yourself a patent. But generally speaking, don't feed the trolls. Be part of what's next. So use open source hardware for your next project. Become a pirate. I highly recommend it. And I've done something special for you guys. I made you a list of 67 different resources that you can actually use to build and learn about open source hardware. Now, it's really an ugly list, but what we'll do is, I'm not going to go over it, God forbid, but if you send me an email, and if you want this PowerPoint, everything is hyperlinked, I'll send it to you, and you get to play and have fun. And that's that. And if anybody wants to play with more Arduino boards, I have the 101 that is powered by Intel, and I have 2 of those, and I have one more Maker 1000. So if you work on a hardware project or you just want to play, let me know. Otherwise, it's been a pleasure.
Thank you, Adam. By the way, I'm not allowing any questions on stage, so I'm encouraging you to go and talk to the speakers. The guys are going to hang out till the evening. Adam has few boards to give away, so I'm guessing the first 3 people to reach out will get the Arduino board, which is really, really cool. So I do encourage them, go and talk to the speakers. Anyway, the next guy, Zach, looks a little bit like Steven Seagal. And has a dog which is literally bigger than I am, which is pretty cool. But he comes from Toronto, Canada. And you know how you should never pitch your company saying that I'm Uber off or I'm a Facebook off. Well, Upverter is GrabCAD for electrical engineers. So he's a guy who knows everything about product market fit and customer discovery. Zach, come on stage.
Thanks, Alex. Awesome. Figure out how to do this. Whoops. Okay, awesome. I'm Zach. I used to build robots when I was a child. I think we live inside a simulation. And my grandfather died a couple of days before I was born. The common thread is hardware, atoms, the world that you can reach out and touch. When I was building robots, I learned how hard it was to interact with the physical world, but I also learned how important that physicality is. Software can't move a block from A to B. It can't, software alone can't move a block from A to B. The hell am I saying? Oh yeah. It can't harvest produce, and it can't build new things. In our lifetime, we're going to have the power to simulate our Earth and really any other universe that we want to simulate. I believe it'll be a cornerstone technology, allowing us to ask sophisticated questions on how to run our businesses, our societies, our governments. But we can't simulate a planet in software alone. We need new computing paradigms. We need new devices. One of the largest industries in the world builds drugs and medical devices to help us live longer. But in the last 30 years, they've added only 3 years to my life. In my parents' life. Software alone can't help us live longer. Without new medical devices, without implants, without drugs, my parents may never get to meet my children either. These are the experiences that convinced me that software alone won't solve the biggest problems in our world. That the biggest problems in our world are inherently physical. They're messy. They're made up of atoms and hardware and physical bits. And our ability as a species to build hardware, manipulate atoms, is essential for our longevity, our survival, our evolution. We've seen the end of supersonic travel. We don't go to the moon anymore. We drive slower now than we did in the 60s. The biggest problems facing humanity, water, energy, agriculture, disease, aging populations, will all be solved through hardware. Software will play an important role, but Snapchat isn't going to bring fresh water or reliable energy to 1 billion homes in Asia. Hardware will. We hear over and over again that startups are changing the world. Really, they all are. They're all on a mission to change the world. All of their investors believe it, all their employees believe it. Doesn't matter if they're delivering food, or driving you around, or shipping you underwear. They're changing the world. Trouble is, they aren't. It's the grandest of startup lies. The whole industry is really built on it. We all come into this game wanting to change the world, but we so rarely step back and look at ourselves and our industry. Real legacy, real change requires invention. And all of the greatest inventions in history, all of the inventions that moved humanity forward, were hardware. The telephone, oil, railroads, the computer. So if startups really want to change the world, why aren't we building more hardware? And the answer is because when it got a lot cheaper to start businesses, it became relatively expensive to solve hard problems, to solve real problems. The standard startup nowadays, a simple app powered by cheap labor, making something just a little bit better. Email marketing, good example. CRM, food delivery, taxi apps, you get the idea. We've made it easy to tackle insignificant, incremental improvements to things that already exist, but we haven't made it any easier to invent a better humanity. The future of our species isn't pegged on how quickly we can deliver a burrito. It's pegged on whether we can make water clean, deliver electricity, cure disease. And I'm terrified. I'm terrified that our future is pegged on science experiments, which have been relegated to universities, competitions like the X Prize. The next dynasties will be the founders that actually change the world, the ones that actually make a real difference, the ones that are building hardware. And if we don't make it easier for people to solve hard problems, many of them might not get solved. The solution is an ideological shift towards bigger problems. We need to embrace the big, the hairy, the crazy audacious. We need to call bullshit on analytics, marketing startups changing the world. Our incubators need to celebrate the impossible companies, not the ones that can be built in a weekend. We also need infrastructure. We need to make it cheaper to work on the impossible. There are 1,000 companies in the world that will help you send a marketing email. There are 0 that will help you design a new power plant. There are 0 that will help you design a new computer. There are 0 that will help you simulate a new drug. And the design and engineering and CAD software, the tools being used by the ambitious founders that are actually changing the world, are decades out of date. The thing holding hardware back isn't physics. It's not a law of nature that hardware has to be hard. Many, many years ago, the people responsible for the tools that hardware engineers use to design the future stopped innovating. the tools started getting in the way. And ironically, at this point in time when we need hardware and we need hardware engineers more than ever before in history, it's also become incredibly hard to be a hardware engineer. Instead of helping them find innovative solutions to impossible problems, the tools are getting in the way and pushing them away from hardware, pushing them away from solving big problems. This is my company. This is why I founded it. I founded Upverter to make hardware less hard, to try and build tools that empower engineers with state-of-the-art technology, knowledge, support. We want to make hardware engineering more accessible. We want anyone to be able to do it anywhere in the world. And we want the tools to fade away. We want engineers to be truly creative, not fighting with a tool to do their job. But the world needs more companies like us. It needs tools for designing medical devices. It needs tools for designing power plants, for designing food and genes and water purification. We need tools to help solve the world's biggest problems. And part of the ideological shift also has to come from the founders and the investors that back them. They need to take on bigger problems. And we're starting to see just a little bit of this. It looks a little bit like Google and their self-driving car project. More people die every year in car accidents than from smoking. $1 trillion is wasted while people sit in their cars wanting to be somewhere else every year. But there's 1 billion cars on the road. Legacy cars, old cars, not smart cars. And just the scope of that problem is daunting. But Google and what they're trying to do with the self-driving car may actually have a greater impact. Solving transportation may actually generate more money than selling ads. That may be their legacy. We see it with SpaceX and their mission to colonize and explore space. Elon Musk realizes that if we remain a single planet species, we will fail. That despite all of our good work over the past couple of years, the Earth is doomed, and we doomed with it. The sooner we can spread to and thrive on other planets, the sooner we can guarantee the survival of our species. And while launching satellites and building cars are really, really impressive, Elon's actual legacy might be saving us from extinction. It looks a little bit like lab-grown meat, solving greenhouse gas emissions, feeding billions of people. And food accounts for about 1/3 of the world's GDP. Simultaneously, it's brilliant business. It's an opportunity to take a cut of the world GDP, and it's the single greatest environmental initiative anybody could ever take on. It's going to be very difficult, but the founder that commercializes the future of food will also be the richest yet. These are big, hairy, audacious problems. They're problems that can only be solved through hardware, and they're solutions that will create the next dynasties. I don't believe you need to be Google or SpaceX or work in a university lab. I don't believe that you need to have millions and millions of dollars to work on hard problems. But I do think we need an ideological shift. I think we need a few founders that are willing to bet bigger, a few investors that are willing to back them. And the rest of us need to come together as an industry to take down those barriers, to make it easier to work on these big, impossible problems. Imagine if it wasn't just 3 examples. Imagine if we really did have a shift towards the big, the hairy, the audacious. Imagine if we called bullshit on the little problems. I think instead of startups delivering food, we'd see startups inventing food. I imagine a world where kids can build med tech, where we build power plants on the weekend, where founders can take on the impossible problems. Investors and accelerators fight to fund the future of our species. And the tools and building blocks exist so that we can work on hard, impossible problems instead of on just the app of the week. I challenge you to be part of this shift. The action that I want you to take is I want you to challenge your thinking. Could your startup be working on something bigger? Could you be using and embracing new tools and new ways that make the future easier to build? Could you build tools that make the future easier to build? Could you invest in bigger ideas? What kind of legacy do you want to leave behind? I challenge you to actually change the world, to make it profoundly better, and not just for the affluent, the Western, the iPhone owners. Whoops. Not just for the affluent, the Western, the iPhone owners, but for our species, for humanity. I believe startups can tackle bigger problems. I don't think we're limited to the small, the incremental. I believe there are dynasties up for grabs right now, and I challenge you to try to change the world. Our species has a future, and it depends on nothing more than a few of us committing to working on really big problems. They're going to be messy. They're going to be physical, atoms, hardware. But I think somebody will try. And I think it could be you. That's me. Thanks.
Thank you, Zach. Here's a gift for you.
Thank you.
I forgot it for the last guy, but I'm wearing his T-shirt, so that kind of makes up for it. Thank you, Zach.
Thanks.
The next speaker, before I introduce the next speaker, I want to welcome President and the First Lady to the crowd. Thank you for being here. The next speaker, Maarten, so he comes from London, and we were having discussion yesterday that Zach and Adam were quite amazed to hear that the Tallinn airport has more than 1 million passengers going through the airport every year. But for some reason we screwed up with Maarten, so he missed his connecting flight and had to take a bus from Riga to Tallinn, 6 hours. Very, very embarrassed for that, so next time I'm going to pick you up if that should ever happen again. Maarten is one of the smartest guys I've ever met, so if you talk to Maarten, it's like talking to the encyclopedia. And this is the guy who's actually tackling these big, audacious, and hairy problems. He's a vice president of IoT at Ubuntu. And without any further ado, I want to welcome Maarten you on stage.
Thank you. Good morning. I want to talk about constructive innovation, and I couldn't have chosen a better introduction. Zach talked about all these audacious things that we need to change. And he is actually a constructive innovator, because constructive innovation is about letting those app developers, those hardware innovators, all work together with established corporations that are being disrupted at this moment and create new industries. Who am I? My name is Maarten Ectors. I work for a company you might not know called Canonical. We do open source software. Our most important product is Ubuntu. It powers about 70% of the cloud. Customers are the Googles, the Amazons, Walmarts, Microsofts of this world. If Ubuntu goes down, Uber, Netflix, Airbnb, and all these companies go down. But what am I really caring about? Well, if we want to sell our products everywhere in the world, we need to make sure there's people that are able to buy them. We can't just go and disrupt all these companies out there that offer good jobs to people and create a startup that, yes, it's worth $1 billion, but it generates 50 million and like a low number of well-paying jobs. We need to actually create a bigger middle class that can buy our products, that can work and have a meaningful job, that can buy and construct together with us. So how can we do it? First of all, who's into hardware here? Oli? Okay. Probably because, like, you like to suffer, hardware lover. Like, I don't know why you want to be in hardware. Like, the hardest problems in the world, you all combine them into one company. You have to raise more capital than anybody else. You have to design a hardware product which is incredibly tough. You better patent it and trademark it, because even the biggest names had problems with that. Then you need to test and certify it. Thank you very much for all these different certification bodies, these different voltages, everything about that really makes your life so much easier. And then you need a global brand to sell it everywhere. You then need to go to the Walmarts and the Amazons of this world and say, like, I have the perfect thing for you. Go and sell it for me. You need to produce enough of it, have the right inventory, have the right way to ship it, and then the big day comes. And what happens? Well, one of three things. Either you don't sell, sorry, game over. You do sell. And 5 minutes later on Alibaba, there's a perfect copy that is cheaper. Or 5 competitors come into the market and Amazon puts them higher because they're 1 cent cheaper. So your margins are going down. So you're in a difficult market. Who works for an enterprise, a corporation? What do the rest work for? Okay, what's your problem? You need to innovate, because otherwise you get disrupted. How does that work in a corporation? Well, your daily life is all about business as usual. You need to get budget. For that, you need to have a business case. Then you need to do something, so you need to launch an RFP, and that's how you work. Now, if you want to evolve your product, you go to your customers, then make a business case, then do an RFP. Now, if for one strange reason you want to innovate, you also need a business case, but since nobody in your company understands it, you actually need to launch an RFI before you can go and purchase through an RFP. So, and then we wonder, why are corporations not innovating? Why are they making like corporate solutions? This is how telcos send your SMSs. On the left side, you see the architecture. On the right side, you see the protocol. It's hard. Corporate solutions are hard. Lots of people working together, lots of moving parts, and so on. And then disruptive solutions come. Twilio, which is about to go an IPO, how do they send an SMS? To from message. And basically, they're even old school compared to WhatsApp, that with 55 people, sends the double number of SMSs or messages every day than all telcos in the world. Like, think about it. How many people have all telecom operators working on SMSs? 55 people doing 50% more. So large corporations need help. Yes, they can bring your products everywhere in the world, but they have their ways of like moving things that are slow and not always up to date. Then, what if you want to go into mobile apps? Who does mobile apps here? Okay. I hope you're not below the poverty line. Because the reality is, and this is a slide from 2014, most people don't even cover their costs. We're now in 2016, in which the iPhone sales are going down instead of up. So this slide is probably even worse now. So app developers are running out of steam as well. Now let's bring all these things together. How can we have hardware innovators that, yes, make open source hardware, but how do you make money with that? Corporations that can like reach the furthest point in the world, but like get disrupted by 55 people? an app developer that can make cool software to solve your problems work together in a new way. Well, that's what I call constructive innovation, and I think Zach definitely would be a constructive innovator, Adam as well, even if he's a pirate. And how does this work? Well, this is the thing I've been working on for the last years. Software-defined hardware. The world is changing. And to you, this might look like a normal projector with a couple of antennas on the side. No big deal. Well, what are the antennas? The antennas are what's called a software-defined radio. If you want to have the details, it's Lime SDR. It's currently crowdfunded on Crowd Supply. But what it really means is you take an app, you put it on this projector, and then you can enable whatever radio technology you want. So if this projector is in your office and you don't want to put a Wi-Fi next to it, you would put an app for Wi-Fi, and all of a sudden your projector also is your Wi-Fi point. What if in the basement you don't have mobile coverage? Well, you put a 4G app on it, and all of a sudden it becomes a mobile base station. But if I put this in my house and I would connect it through Bluetooth to my smartwatch that I now can start moving, and I would connect it to a drone and let the drone stream video as well, what I could actually do with this box is just chase my kids and see what the drone sees and like chase them around the table. But the biggest message is the hardware didn't change. We're now at a stage where if you put apps and app stores on devices, you can redefine what the device does. There's a blog post that I wrote about like 10 or 12 different other things you could do with this box. And this is only one example. And what is really, really interesting with this whole open source hardware is that the future is this type of hardware. Like, this is the latest Raspberry Pi Zero. Very few people have actually seen it because it's very hard to get. It costs $5, it's as powerful as the first Google servers. But think about a world in which the next 2-3 years, this type of things will be everywhere. And we'll be able to do all types of wireless communications. You could put this easily into any day-to-day object. Everything Zach was talking about could have this in there and could have its own app store. So what you want to do now is to have a way to separate the hardware from the app ecosystem. And let's think about what Zach said. We need everything around hardware, water purifiers and everything for food processing and everything for health and so on. What if we start open sourcing all that hardware? What would happen if we put health devices, water purifiers, and everything that you could app enable on GitHub so anybody could download it? What if we then create app abstraction layers? For a robot, for instance, what would be a good abstraction layer? Left, right, forward, backwards, and optionally up and down. Why would that be good? Well, even a kid could now make an app, and I don't know if you know Scratch, which is the thing kids use that drags and drops. They could make any type of robot move. And optionally, if it can go up and down any drone. So if you think about like app abstraction layers and app enabling any type of device, a robot, a fridge, a network equipment, a 3D printer, whatever you want, and allow anybody to make very simple apps for it that solve day-to-day really hard problems, you can create this whole app store for those type of devices, and as a hardware designer, get money from that app store. So you can actually start giving away your best designs to the world. Because what's the problem with open source hardware? How do you make money with it? So, if you pay me for my app ecosystem that I just created by open sourcing a water purifier, a health device, or whatever, I can still make money. I can share this with corporations that can now put my device everywhere. So the new idea of like, how can you accelerate those audacious problems with hardware that really solves it, is to think about, can others put apps on there? And can I get a revenue share from those? And as such, I can open source any type of hardware. So now, let's make this very practical. Let's go to something as complex as an MRI scanner. What would happen if somebody tomorrow left one of the big MRI scanner companies and started designing an MRI scanner and put it open source? Well, hospitals would say like, oh, I'll take the design to China or to Taiwan and let somebody produce it cheaper than I can buy it now. I'll buy support and apps from an app store because it will only be the hardware. And I can sell new services to people that unfortunately have to use it. So for a hospital, there's 3 big advantages. Now, the one who produces the hardware also has clear advantages. They just need not to invest in designs. They can just pick it from GitHub. They can even go to multiple hospitals and say, like, what if 10 hospitals, 100, 1 million hospitals would all order an MRI scanner? My price would go like this. So at that moment, MRI scanners become cheap. And I don't need to focus on software, because reality is hardware and software are 2 different worlds. So if you're into production, you might not want to care about that one. Now, why would the designer open source the hardware and not produce it themselves? Well, if I can make this app ecosystem work and this support services work, and I separate them from the hardware, then whoever does the hardware needs to come and talk to me, because otherwise they have an empty box that doesn't actually do anything. So they can still negotiate a royalty fee with whoever manufactures it, if they want to. And they can get all these revenue shares from everybody that offers support services and apps on top. What's in it for the app developer? Well, if you're bored of developing the next thing on your mobile, you might actually go to new markets. MRI scanners could be one, but could be anything, water purifiers or any other type of hardware device that comes out. And you can focus on what you really like best, which is making apps that solve people's problems. But instead of solving a small problem, you could actually solve a problem that saves lives, that cures people, that gives them food and water every day. And probably those apps will give you a lot better revenue share than just making another copy of whatever on a mobile app. What's the advantage for the unfortunate patient that has to go to an MRI scanner? Well, if I have a problem in my head, the hospital could say, like, well, Maarten, if you would pay $100, we could scan your whole body, and there's these 5,000 algorithms. We could go over your whole body, and perhaps, like, we find some other diseases before they actually are going to affect your body very much, and we can cure them. And if you give away the data for research, there's lots of companies that would pay $100. So if you don't have the $100 and you're able to share your data, it would be free for you. What does that mean? Well, if diseases get detected before they actually get into an advanced stage, I would pay less. It would be a lot cheaper, and not only cheaper for me, but cheaper for society as a whole to provide healthcare. And if MRI scanners are there for the grabs and are a lot cheaper than they are today, then even local hospitals could have them. And that would mean millions of lives could be saved in regions of the world that currently are deprived of them. So, new revenues for everybody. The app developer that makes cool apps for all these new devices. The hardware designer that gets paid because support service and apps are sold on top. The corporation that can come in and make sure that these new designs are distributed until the last square mile around the world. We can innovate a lot faster. bring the cost down, and create a sustainable economical model. Because apps here, apps in Australia, and apps in Uruguay are probably not going to be the same. People have different problems all over the world. Apps are the way to solve those. You all have a mobile phone in which you have a unique combination of apps that the person next to you doesn't have. Well, think about this capability on all type of devices everywhere. So what I'm asking here today is to think really hard before you want to be a disruptive innovator. And think about becoming a constructive innovator. And if you're into funding, there's lots of cool companies out there that have the keys to creating this constructive innovation economy. If you're into open source hardware and software, that's the type of thing that is going to change the world. So please, innovate today or have the chance to be disrupted tomorrow.
Thank you, Maarten. Thank you very much. You were spot on time. Unbelievable. So we have another speaker coming. Do I see something driving already? Yes, I do. So it's one of the coolest hardware startups from Estonia. Lauri is a vice president of engineering in Starship Technologies. He's ex-Skyper, so he already worked for Skype before eBay era. He has worked for Ericsson, Microsoft, and now building this. So it's really cool. So Lauri, I want to welcome you on stage.
Hello, I'm hoping you all are having a good day. And speaking of existing businesses being disrupted, what we're doing is we're working on autonomous robots for parcel deliveries. So if you look at the market, then this is an area that's definitely ripe for disruption, and ripe for disruption in quite a few ways. So the models that you have today have predominantly two issues. Number one, it's very, very high cost, and number two, it's kind of slow. So things, instead of coming through you through broadband, they just trickle to you. And you need to wait for a few days, and then finally, when the big day arrives, then you get a call, and the call asks, hey, are you home between 10 a.m. and 3 p.m.? And I generally have no idea where I am. So then you have the question of rerouting and everything like that. And if you look at the model, then it actually can be turned on its head in slightly kind of unorthodox ways, and you can get all those benefits out of it. But the company, so it's been launched by two Skype co-founders, Jaanus Friis and Ahti Heinla. It has its roots in one of the NASA Centennial Challenges. It's kind of a grand challenge type event where NASA is looking for new technologies, and in a way that is a competition and an area where you are staged on Mars, and that has surprisingly many similarities with kind of what we face down here on Earth. So as a robot, you don't really know where you are because Mars has no GPS. Over here, you don't get precise enough information from GPS to know, are you on sidewalks, or are you on public roads, are you coming to a crossing, or anything like that. So many of those principles are directly translatable to this very same robot. We are up to 45 people now across a few different locations. So R&D is based over here in Tallinn, and our business office is based in London, and we're starting a few different operations elsewhere as well. And we firmly believe that we are going to be the first autonomous technology that's going to be rolled out in kind of the public sphere, not inside a warehouse somewhere, on scale. So drones and autonomous cars are still quite far away due to regulatory reasons. And sort of the delivery problem also is an area where, in addition to those delivery issues, you also, for very routine and not super pleasurable reasons, you need to go to the store and spend like an hour per day to get milk or to get whatever else you need. And it really doesn't make sense to use a 5-ton vehicle to deliver like a carton of milk to your home. But as soon as essentially you can put wheels on that same package, then that becomes feasible both in terms of waiting time and also in terms of cost. So what we're doing compared to vans that's crucially different is specifically the delivery time. So we want to get the shortest end-to-end delivery time. And with vans, you get lots of parcels coming in very efficiently into an area, and then the van spends the next half day or day delivering those packages in series. So if one person isn't home, then the next person suffers because you never know exactly when your package is going to arrive. And how that world can be put on its head is this model. So you can actually open service areas, you can pre-deploy packages in bulk into that area, which is very, very efficient. And those packages can just wait for you until you get home, and we have technology, kind of a mini warehouse in which they live. So it's kind of a parcel or postal locker that's automated, but in addition to that, it also loads the robots. And you can have quite a few different models depending on what kind of a business you have. And the common thread for all of these is that you get quick and cheap deliveries. And from a user perspective, this is essentially how it looks like. So those packages physically are taken to your neighborhoods, and you get a notification that it's here, you have a few packages waiting, you can choose the exact time when you want it delivered, down to a 10-minute slot, 5-minute slot, or even a couple of minute slots. And once you confirm that you are home, then parcels get automatically delivered into the robot, and then they start driving. And this is roughly what it looks like. So it has lots of things on this picture, but what's the absolutely most important part is this lower right corner here, which is the robot needs to know where it is to be safe and to be kind of viable in autonomous driving throughout that entire area. And what we do is we heavily use machine vision, and we make sense of the world through cameras. We are anti-lidars. We don't like a number of other technologies that are typically used on very high-priced vehicles like autonomous cars and so forth. We like cameras, and with cameras, you can make sense of the world in a very, very rich way. So let's say with LiDARs, you would know what's around you, but you never know what color is in the traffic lights, or whether you have a walk signal or whether you don't. And with cameras, we can just tack that on. So we can be much more iterative in rolling out features. We can become much smarter and distribute it through or to all of those robots. And the parcel itself ends up in a compartment much like this one. So it is taken from this postal locker type hub, or in some cases, you might have the same module deployed to a local store where you also do picking, and you put it inside the compartment after removing the previous baskets, after replacing the batteries, and you're ready to roll again. And this combination of lots of robots, between 5 to 20 robots for a given area, and this automated warehouse is something that you don't really want to do with traditional delivery. So you don't want to have a person delivering just one package, but if your end goal is to shorten the delivery time for absolutely everybody and give excellent predictability, then that's exactly what you want to do. You want to have the robots be as cheap as possible, but also to be as smart as possible, and then roll to your doorstep, and you can take the goods out of it and proceed from there. And we've been in operation for just over 2 years now, and as part of that, we have a fleet of 20 robots or so, and we're building an additional 100 this year. We have already driven 5,000 kilometers in public environments. So if you roll around in Mustamäe, you often see the robots. If you go to London, you see the robots. And you also see them in a few places in the States. And we also are right now mapping out new areas where we start doing autonomous deliveries. So as part of the first line, we mostly do remote operated and kind of pedestrian testing, but the pedestrian acceptance has been overwhelmingly positive. So now we're also rolling out areas in preparation for starting customer pilots. And these are some of the areas that the robot has been seen in, and you will see them pretty soon in a number of other places. So there will be a few announcements coming up in the next weeks and months. Thank you.
Hello. Thank you very much, Lauri.
Thank you. And the robot will be around here for a while, so you're welcome to come step up to us and take a look inside and chat to us about it. So thank you.
I was thinking meanwhile that what if Starship would open source the design? I could then go and steal one and make a lawnmower out of it. So that's my plan, so I'm waiting for that to happen. Anyways, to wrap it up, as Zach says, my experience is that when you're tackling big, hairy problems, it's very, very difficult to do alone. So if you're a hardware startup looking for funding, come and talk to me. If you're a hardware startup looking for advice, come and talk to Zach, Maarten, Adam, Lauri. Thank you.
So thank you to all the hardware guys. Thanks.